So what exactly is up with these brackets? Why are they there? If they're blank, what's the point? Well, to answer this question, I'm going to draw your attention back to something you've already seen before. And that something you've already seen before is the command console.writeLine. Now you've used this a ton of times, and in this you know that writeLine does a very specific task. It's a subprogram that performs a single task. In this case, the single task is to write text to the screen. Well, that text is defined by whatever you put inside these brackets, some form of string. So it might be something like hello world. That means that when the line of code is executed, hello world will be displayed in the console window. It's fairly straightforward. This data is what is required for the writeLine command to do its job. If we didn't supply this data, it wouldn't work. WriteLine would fail, the command would fail, the code wouldn't even compile. You're going to get an error message. So this isn't the only command that requires something like this. We've also seen other ones, things like math.pow. Math.pow requires two pieces of information, a base, let's say 3, and an exponent, let's say 2. This is the same thing as saying 3 squared, which is of course equal to 9. Now, what's actually happening here, you see that we have two pieces of data that are required for the POW subprogram to do its job. It's going to take the base 3 and square it, according to the data given. We separate these pieces of data by a comma again. Not all subprograms require data. So things like console.readLine, that is a subprogram, but it doesn't require anything from us as programmers for it to do its job. The subprogram that we just finished creating 2 seconds ago, displayInfo, it doesn't require any extra information to do its job. It just does the job. Every time we run it, it is going to display name Mr. Lane, profession teacher. Now, of course, that's not very flexible, doesn't do a whole lot, but it works and it's not going to create any errors. So it doesn't need anything extra to do its job. So we give a special name to these pieces of data that is required for the subprograms to do its job. That name is something called a parameter. Sometimes they're also called, aka, arguments. Okay, so a parameter or an argument, well, it has a very simple definition. It's a temporary variable that stores data required by the subprogram to do its task. Well, this is very interesting. The idea that it's a temporary variable. Every variable that we've created up to this point is not temporary, it's permanent. So when our program runs, all those variables that are created at the top of our code that we create up here below the class line, they're in existence for the entire life of the program. We can access that data anywhere. Well, the difference is now we can't. If we create a parameter of our subprogram, it is only accessible and only in use for as long as that subprogram is currently executing. So if we were to create a couple parameters for our displayInfo subprogram, the variables, or the buckets as we like to call them, the buckets would come into existence as soon as the subprogram starts executing. It would perform its task, and as soon as that task is complete and it hits the closing bracket on displayInfo down here, those buckets are destroyed. They're gone. We'll never see them again. Those buckets only hold copies of information. They don't hold anything else. It's just information that's copied over for temporary use. So if we made any changes to those buckets, it wouldn't matter, because as soon as the subprogram finishes, those changes in the buckets they're held in are gone. It's only temporary data, as opposed to our normal variables, which are permanent data in existence for the entire program. So these are our parameters, or our arguments. Temporary variable that stores data required by the subprogram to do its task. Now be careful about this. It only needs the data required to do the processing, not where it's going to store it. So for example, if I created a subprogram called calculate rectangle area, obviously that's going to calculate the area of a rectangle, and it will require two arguments or two parameters, the length and the width of the rectangle. And that's all I would set up. I wouldn't set up a third parameter like called area or anything like that, because that's not required to do the calculation. That's where I'm going to store the result of the calculation. So I only set up the data that is required to do the processing as a parameter. Well, let's figure out how we actually do that. How do we set up these parameters? It's fairly straightforward actually. It's just like creating any other variable. We go inside these brackets and we say, okay, I'm now going to define all the parameters that I want to use that I need for my processing. In this case, what I'm going to do is instead of always outputting name, Mr. Lane, and profession teacher, I'm going to allow us to supply different names and professions whenever we call display info. So to do this, we define two variables, one for the name and one for the profession. So we're going to say string username and string user profession. So what you can see here is they're just like regular variable definitions. There's nothing different. And then for each one, I separate them by a comma. So that's fine, but you'll see that there's some issues. We still haven't used this data, so let's try using it. Let's instead of putting Mr. Lane here, let's get rid of that, and let's concatenate the username. And we'll do the exact same thing for the user profession down here. Get rid of that, and we'll concatenate user profession. So here we see we're actually using the data. But at this point you should be asking yourself, how's that work? Username and user profession doesn't have a value yet. Well, let's put that at ease. You're going to make an assumption. Whenever you use a subprogram that has parameters, as a programmer, you may use the assumption that all parameters will have values when the code inside of a subprogram is executed. And the way that is enforced is this signature line that we created here acts as a contract. That contract is between two things. In this case, the two things are the programmer and the subprogram itself. And the contract is very simple. The subprogram will do its task as long as the programmer supplies the data required to do the task. So let's think the stamp example again. What is the one thing that a stamp requires to do its task? Ink. If we do not supply it with that ink, all you're going to get is blank paper when you're done. No stamp is going to be actually on the page. So this is the same thing. We're saying we will supply username and user profession in this case with data every time we use display info. If we don't, the program will not operate because we are not satisfying the contract. It is our job as programmers to satisfy those contracts, even if they're contracts that we created by creating our own subprograms. So we can see that up here, display info is all in red. That's because we haven't satisfied the contract. And if I mouse over, you can see the error message. It says no overload method, display info takes 0 arguments. So it's saying there's no such thing as a display info subprogram that takes 0 parameters or 0 arguments. There's only one display info subprogram, and it requires 2 parameters, a string username and a string user profession. So let's try this out. Let's put in, let's say Bob, and Bob is going to be a carpenter. So how does this actually work? Well, when the line of code executes, when this one line of code executes here, display info, what happens is that the text from Bob gets copied into the bucket username, just as the text from Carpenter gets copied into the bucket called user profession. That's it. It's just a copy. There's nothing special about that. It's just a copy. And remember, as soon as display info is done executed, those buckets are deleted anyway, so it doesn't make a difference. So that data is copied into those variables, and then the code executes. So when this line, first message box command runs, when it goes into memory and says, hey, what's the current value of username? Well, it's going to be Bob, because that's what we copied into the bucket. Same as user profession is going to be carpenter. So if we run the program right now, we click on the button, we'll see that we get Bob the carpenter. Now this is one aspect of this. So let's show how we can duplicate this and perform the same action again, but this time getting different results. Let's say Jane is a CEO. And if we run the program again, this time we're going to get Bob the carpenter, no different, but now we're going to get Jane the CEO. We called the same code twice, but we called it with different values for the parameters. What that essentially means is we got two different results from the same code. Well, that's like having different colors of ink for the stamp. It's still doing the same task, but because it has different data, we get two different results. It's pretty much the exact same idea. Now the cool thing is that we don't always have to have literal values here. We can have variables here as well. So let's say up here I created a variable. Let's call it string, let's just call it name. String name, and I'm going to give it the value Frank. And I'm going to have another one, string profession. And we're going to give it the value, I don't know, janitor. So Frank the janitor. Now I can actually use those variables. Let's create a third display info here. You'll notice when I open my brackets, the IntelliSense tells me what display info is expecting as part of the contract. Two strings, one called username, one called user profession. And inside of here, instead of putting literal values like Bob or Jane, I'm going to use my variables, name and profession. Now this is where things start to get confusing. Because if we did something like this, if we came in here, we said, alright, pass in the value of name into here, and then use it. What if I did something like this? User name is equal to George. Well, what happens to the original name variable? Nothing. Absolutely nothing. And the reason being is because what we said before. The data is copied into the parameters. It's a copy. The original data is left alone. So it's not changed, it's not affected, it's never touched again. So the way this is actually going to execute it when we look at our code is when it gets to this third display info line, it's going to say, okay, what's the current value of name? Well, it's going to go up and says, oh, name is the value Frank. So it's going to substitute that value, that variable called name, for the text Frank. And then it's going to copy the text Frank into the username bucket. And that's going to follow the same process for profession and copy the word janitor into user profession. The name and the profession variables are left alone. They're never touched again for the rest of this program the way we have it laid out. So changing the username to George down here will not affect the original name variable. In fact, the only result it will create is that everybody will be named George, no matter what, because where we put that code. So if we run this, when we call the subprogram, we see that name is George, carpenter, George, CEO, George, the janitor. It's always George. And that's because of this line of code that we put right here, which kind of overrides whatever data we had in for username to start with. Get rid of that. So now we would actually get good data. So from this point, we know that we have created our parameters. There's one other piece or important piece of information about parameters that you need to realize, and that is that order matters. So if I change these things around, and if I accidentally put CEO here and Jane in the next one, the computer does not know which order you're displaying or which order you're using these things in. All it knows is that it's expecting a string and then another string. Well, we still did supply it with two strings, so it's not going to break the program. The program functionally still works. But that doesn't mean we're going to get the results that we expect. We're going to get Bob the carpenter. But then we're getting CEO, whose profession is Jane. So we see that things are backwards. So we have to make sure that we've properly set up the parameters as required. Just make sure that I've covered everything here. Different results every time. We have our separated by commas, type order matters. Yes, and that is everything that we need to know about parameters for now.